as I mentioned before, when it comes to switching in the CCIE routing and switching exam, the only switches that we actually care about and the behavior of those switches are 3560 switches running 12, 2, 44 or 46 SE code. And these are the exact switches that you have in your pods. Well, all except Cat 1. Cat 1 is slightly older, 3515, what you have. But in the pod that I will be using today, I will be using 4 3560 switches to demonstrate the behavior of them. So when we talk about Ethernet switching, what we are going to talk about are the interfaces and interface types. We are going to talk about spanning tree. We are going to talk about some advanced spanning tree features. We are going to talk about ether channels and about anything else that actually matters about these switches. Again, what I'm going to skip talking about today is going to be QoS, and I will talk about QoS when we actually talk about QoS. So without further delay, let's continue with this. So when we have a 3560 switch, from now on known only as the switch, what are the possible interface types that we can have on this switch? And mind you, I'm not asking about gigabit interfaces or copper interfaces or fast Ethernet interfaces. What I'm asking about, what are the interface modes that the switch can operate in? How can I configure the interfaces? What are the possible configuration modes for these interfaces? So let's see what you think about this question. Access interfaces. We can have trunks. What else? We can have layer 3 interfaces. Very good. What else? Oh, there is more than that. Well, we can have switch virtual interfaces, but those are not physical interfaces. Those are logical interfaces on the router, but okay, we can have SVIs, very good. We can have monitoring interfaces. Now that's an interesting one. Very good. Okay, what else? Well, we can have ether channels, that's right. We can have private VLANs, that's very good, which can be either host ports or can be promiscuous ports, very good. What else do we have? What about, for example, dynamic interfaces that can be either auto or desirable, which basically is DTP. We can have that as well. So these are just some of the interface modes. And you can see in about, what, 30, 40 seconds, we have come up with these answers. So what I'm going to be focusing on mostly today are these interface types here. Now, these interface types here are slightly more advanced, or I'm not going to say more advanced, but they are not really regular. I wouldn't call them regular interface types. This is not something that you will encounter on regular basis, but these access ports and the trunk ports and the layer 3 interfaces, dynamic interfaces, is something that in the CCIE lab you will be encountering pretty much all the time. So when we take a look at 3560 on the switch, the default interface type is dynamic auto. Now, what dynamic auto means is that DTP is enabled, that DTP frames are sent. Now I'm waiting for a ding, someone to complain about this, but the switch is not actively negotiating the trunk. Now, this might sound a little bit confusing, and I wouldn't blame you for that. So I'm saying here that the DTP is enabled on dynamic auto, which is okay, and the DTP frames are actually sent out when the switch is not actively negotiating the trunk. So what's the point of those DTP frames being sent out? And your question, if you are asking yourself or me, that question would be perfectly valid. What would be the point of those frames? There is really no point other than telling the switch on the other side that we are willing to negotiate, but these frames are not actually an act of negotiation. So to show you this in action, what I'm going to do is I'm going to use just a couple of my switches. So I'm going to have, let's say, switch 1 here, and I'm going to have switch 2. They're going to be connected on fast Ethernet 0, 24 on both sides, and I'm going to be using the default configuration on 3560. And as I say, the default is dynamic auto. So let me bring in those switches there. So here I have Cat1 and Cat2, and I have done just minor pre-configuration on these switches. Basically, I have just shut down all the interfaces on these switches except the reason I did the shutdown on these ports is that I want to have only those ports that I care about up. And in my case, this is fast Ethernet 024. So what I'm going to do now is I'm just going to bring this interface out of shutdown here. Oops. So I'm going to bring this interface here out of shutdown. So this goes in here. So at the moment, I should be seeing the CDP neighbors. Well, maybe not that fast. Actually, it's going to take some time for the CDP neighbors to show up here. Oh, there we go. So here I have Cat2 as the neighbor, and here I should be seeing, well, at some point Cat1, but let's assume that that actually worked. So if I run the command show interface fast Ethernet 24 switch port, which is a very, very useful command, I'm going to see what is the current operational mode of this port. Now I can see that the switch port is enabled, which basically tells me that this is a layer 2 port. I can see that administrative mode, how the interface was configured, is dynamic auto, but it is actually operating as the static access port. Now if I take a look at the configuration on the other side, I will also see that administrative mode is dynamic auto, but that the operational mode is static access. So if these frames were indeed sent, wouldn't the switch negotiate the trunk? Well, let's take a look at that. So to take a look at this, what I'm going to do is I'm actually going to run a Wireshark in my pod. So let me just start it up. I should have really started it in advance, but it will take just 1 second to start it up. So here I'm going to bring my Wireshark. There we go. And what I'm going to do now is I'm going to add one more device here. So my Wireshark is actually connected to switch 1. So there is my Wireshark box. And this is fast Ethernet 03 that is connected to this box. So what I'm going to do now is I'm simply going to go and configure this interface on Cat1. So show run interface fast Ethernet 03. As you can see, it is in the default configuration mode. And the only thing that I'm going to do on that interface is I'm going to do no shutdown. But not before I actually, oops, what was that? Let me bring my Wireshark. Where is it? There we go. So what I'm going to do here is I'm going to start the capture on Cat1. And I'm going to say that I'm interested in only hearing or seeing DTP frames. So if I go to my Cat1 and I do no shutdown, let's see if I'm actually going to get those DTP frames in. So the interface should be changing state to up. Well, there we go. It changed state to up. Now, let's see if we are getting actually any traffic here. So, so you see, I'm getting some traffic. So I'm getting spanning tree traffic. I was getting CDP. So there is some communication happening there, but apparently I'm not getting any DTP. So was I maybe lying to you that DTP frames are not sent? Well, if we wait just a little bit, we are actually going to see DTP frames. And here they are. So this is my cat switch sending the DTP frames to my Wireshark box. So this interface here that is configured using the default configuration. So there we go, Fastnet 03. This is the configuration, nothing special there. We can see that it is actually set to dynamic auto. It operates as the operational access port, but we can see that negotiation of trunking is on, and that in fact it is sending the DTP frames. It is announcing to the device on the other side that it is willing to negotiate, but it is not actually actively negotiating the trunk. And because if it was actively negotiating the trunk, my connection between switch 1 and switch 2 would actually be a trunk, but it is not, it is an access port. So if I wanted to use DTP to actually make this interface a trunk, I would need to make at least one of the sides desirable. So let's do that. Let's make this connection here operate as the trunk. So I'm going to go to interface Fastnet 24 on either switch. That's okay. You don't have to do it on both. And I'm going to say switch port mode dynamic desirable. When I do this, the line protocol will change state to down, and then the line protocol will change state to up. There we go. And if I do show interface Fastnet 24 switch port, what I will be seeing here is that now the administrative mode is dynamic desirable on this switch. The operational mode is now trunk. And this is where we reach an interesting bit. It says here that the administrative trunking encapsulation is negotiate and that they are actually operating as ISL trunks. This negotiate is something that I want to talk about. We all know that on Cisco switches there are two trunk modes. They are ISL and 802.1q. Now, ISL is Cisco proprietary and 802.1q is standard. But less widely known is the third mode, which is negotiate. And this is operating only when interface is dynamic. That means when the interface is enabled for DTP. This mode, I have a nickname for it, is I don't care mode. Which means that switch is telling the other device on the other side, okay, I'm willing to be a trunk, but I don't really care which trunking mode we use. Are we going to use .1q or are we going to use ISL? It's all the same to me. Now, if both switches are in I don't care mode, this means that they are both supporting ISL and .1q. You will never have negotiate mode sent by a switch that doesn't support ISL. Now, if the switches support both ISL and 802.1q, the preference will be given to ISL. That means if both of them are in I don't care mode, they're actually going to fall back and use the ISL. So basically, the possible combinations that you have here is that, let's say, trunk encapsulation and DTP. So these are the possible combinations that you can have. You can have negotiate that speaks to negotiate. Then you can have negotiate that speaks to ISL. You can have negotiate that speaks to .1q. You can have ISL that speaks to ISL. You can have ISL that speaks to .1q. And you can have .1q that speaks to .1q. Now, if we have this situation here, the trunk will be okay and the negotiated protocol will be ISL. In this situation here, you are also okay because this side here doesn't care. This one requires ISL, which means that we will negotiate ISL. Similar situation is here. The trunk will form, but we will use .1q because this side doesn't care and this side here uses .1q. This is also okay situation, clear as daylight, ISL, ISL. Now, if one side requires ISL and the other one requires .1q, this is the situation when we are not okay, because there will be no trunk here, because this side requires ISL and this side requires .1q. None of them is willing to negotiate the trunking encapsulation. Now, in the last example, when we have .1q on one side and .1q on the other side, we are again okay, and in this case, we'll be using .1q. So these are the possible combinations of trunking encapsulations if you are trying to use .1q and actually negotiate the trunk on two sides. Now, another important thing to know about the DTP are the possible modes. We can have it in desirable mode, we can have it in auto mode, and we can have it in on mode. Now, when you create the trunk, when you say switch port mode trunk, you are actually still running the DTP. Again, let me show you that. So I'm going to go back to my terminal here, and I have that interface facing my Wireshark. So I'm going to say here, let's start by shutting it down, and I'm going to say switch port trunk encapsulation.1q, switch port mode trunk. So now I'm enabling the trunk on this interface. And if I do no shutdown, if I do show interface fastnet03 switch port, what I'm seeing here is that the administrative mode of the interface is trunk. That means we are not really willing to negotiate the trunk or not trunk. We are the trunk. We can see that operational mode is down. Well, okay, let's try again. That operational mode is trunk, and administrative encapsulation is now set to .1q, and the operational mode is set to .1q, but negotiation of trunking is still happening. So let me take a look at this. So I'm still running the capture there. I'm just going to, okay, let me just restart the capture. So there we go, Control R, restarting the capture, and take a look. I'm still, okay, so maybe need to apply this. Let's wait a little bit for DTP to start arriving, as just as before. It's going to take a couple of seconds. Of course, whenever I want to reproduce something right away, there we go, just as I cleared it. So if I apply the filter, there we go. You see that even in the mode on, we are actually sending the DTP frames. So now this switch is running the trunk, but we are still sending the DTP frames. So this is why I say that you have 3 modes of operation in DTP. Now, given that the encapsulation is matched, that the trunk will form based on this table, let's see which of these modes are going to result in an operational trunk. So what are the possible combinations? We have, so let me see DTP mode combinations. So we have desirable and desirable. We have desirable and auto. We have auto and auto. Oh, sorry, I think I'm missing one, so let me just delete this stuff very quickly. So we have desirable and on. Then we have auto and auto. We have auto and on. And we have on and on. In the case of desirable and desirable will be okay, and the trunk will also be okay. Bear with me, this is going to make sense a little bit later on. Now, if we have desirable and auto, this is okay configuration. The trunk will be negotiated correctly, and the trunk will be operational. If we have desirable and on, again, we are going to be okay, unless we actually have a mismatch in the operational mode, in the trunk encapsulation mode, because we can easily imagine the situation. Hold on a second, I think I lost the my table here. just 1 second, I do apologize. So here, imagine that this on here was, for example, using .1q, and that this side here was using ISL. If that was the case, this is obviously not OK configuration, and there will be no trunk negotiated on the desirable side, but this side here will actually be a trunk. Why? Because it is not negotiating. It will always be a trunk. So we might actually have a mismatch going on there. Now, if I have auto and auto, there will be no trunk. If I have auto and on, in this case, we are going to be OK because on here is very similar to desirable mode. It will actually send the frames that are actively negotiating the trunk. So auto side will actually form a trunk, and we will have operational trunk again, unless we have a situation that is similar to this one here, in which case this side will be a trunk and this side here will not be a trunk. Now, if we have on and on, if the encapsulations match, we are going to be OK and the trunk will be operational. But again, if we have a mismatch, let's say that this side wants ISL and this one wants .1q, if that is the case, we are not going to be OK, and this side is going to think it's a trunk, this side is going to be a trunk, but there will be no operational traffic passing through because the encapsulations won't match on these two sides. The next thing that I'm going to talk about, we are still on the subject of DTP. So DTP has a relationship with VTP, and VTP is VLAN trunking protocol. Now, VLAN trunking protocol is Cisco's proprietary protocol that can be used to distribute the information about VLANs from one switch to another. As far as you are concerned for the RNS lab exam as it is right now, you care only about VTP version 1 and VTP version 2. There is also a VTP version 3, which is not supported on the equipment that you will have in the lab. Actually, it's supported by the equipment, it's just not supported by the version of the iOS that you will have in the lab. So the only thing that we care about are VTP 1 and VTP 2. And these can operate in 3 modes. They can operate in transparent mode. They can operate in server mode. And the switches can operate in client mode. Now, if you read Cisco press books or Cisco training material and so on, you're going to encounter an unusual description of the difference between VTP version 1 and VTP version 2, especially in transparent mode. Now, one of the things that I will send you together with the files at the end of the day will be a link to a blog post that I have written in which I actually dispel with this myth about the difference in behavior between VTP version 1 and VTP version 2 in transparent mode. So as far as 3560 switches are concerned, with the version of code that you will have in the lab, VTP version 1 and VTP version 2 behave in identical manner. So what are the characteristics of the transparent, server, and client mode? In transparent mode, VLANs can be let me create a table. So local VLAN creation, or let's say modification. Remote VLAN modification. That means, can the update from the network change the configuration on our network? So in transparent mode, and let's add VTP packets are forwarded in this mode. So let me just quickly modify this. So here, I'm going to have transparent, server, and client. And let me add one more field here. So I'm going to need some space to do that. So one more field that I'm going to add here is high VLAN numbers. Actually, I'm going to add one more. Just remember that we can always add more stuff to the tables. Tables are good. So let me then change this a little bit. So high VLAN numbers. And that's basically VLAN numbers above 1005. And here, advanced features. Like, for example, private VLANs. So in transparent mode, this is bad, so I'm just going to do it like this. In transparent mode, we can create local VLANs. However, the remote VLAN updates are not allowed. That means that the switch will receive the the VTP update. It will receive the update from the network, but it will completely ignore it. It will also not send any updates to the network. So it's kind of operating in a similar fashion that to VTP being turned off. It's not off, but it still operates there. The packets will be forwarded. That means if the switch receives an update from one other switch, it will actually send it to other switch if domain matches. That means if the VTP domain is the same, the packet will be received and then forwarded on to other devices. If the VTP domain does not match, the packet will not be forwarded. And that's one of the myths about VTP transparent behavior that says that this behavior is different in VTP version 1 and VTP version 2. It isn't. The high VLAN numbers can be created and private VLANs are actually supported in this mode. So that was transparent mode. Let's take a look at the server mode. We can create local VLANs. We can receive and send updates from the network, and also the VTP packets are forwarded, given that the domain is actually managed, that the domain actually matches on the local switch and on the packet that is received. High VLAN numbers are not supported on 3560. On some other switches, like for example 4500s, which you don't have in the lab, you can actually have the switch operate in the VTP server mode, and you can still create the local VLANs that are high numbered, but that information will not be propagated to other switches. On 3560, if you try to create a high VLAN number with VTP operating in a server mode, it will not be possible. And you cannot use private VLANs with the server mode. With the client mode, you are not allowed local VLAN database modifications, but we will be sending updates on the network and we will be receiving updates on the network. The VTP packets will be forwarded as long as the domain is actually matching, and the high VLAN numbers are not actually allowed to exist. And of course, in the client mode, just like in the server mode, it is not possible to have private VLANs. So that was very, very brief overview of VTP capabilities. Now, the relationship between DTP and VTP is, as I said, very unusual one. So let's say here that we have switch number 1 and we have switch number 2. And we have the link between these two that we are just bringing up. So link is now down. When the link comes up, and let's say that here it is desirable, and let's say that in this side here, it's also desirable. So technically speaking, at this point in time, this is not a trunk. What is going to happen when this switch here sends the DTP frame to negotiate? Inside the DTP frame, so this is DTP frame, we are going to encapsulate it in the frame, in the DTP frame. There will be information about the VTP domain. Let me show you that. So I'm going to go here and I'm going to just select one of these DTP packets and I'm going to expand the information about the DTP. And you see this line here that says domain. Now, right now it's empty because at this moment there is no domain configured on my switches. So if I go back to my cat1, for example, if I do show VTP status, I'm going to see here that that is actually true information. There is no configured VTP domain. And this is a very special case on Cisco switches, because VTP operates in a very, very unusual mode when you don't have the VTP domain. Even though this is a server here, and cat2 is the server right now. So if I do show VTP status, I can see that this is a server, but also it doesn't have any domain. And we also have the trunk running between them. So show interface trunk shows me that between them I actually have an operational trunk. If I go to cat1 and I say, for example, create VLAN 100, I will see that VLAN 100 was created on cat1, but on cat2 here, that information is not propagated. The reason for that is that this is actually an incomplete VTP configuration. What I need to do is I need to set the domain. So this is a very, very special situation now. So on cat1, what I'm going to do now is I'm going to say VTP domain Cisco. So now we can see that the domain is changing name from null to Cisco. Now when I go to cat2 and if I do show VTP status, I can see that cat2 actually learned the domain from cat1. And this is the special behavior that I was talking about. Only when we receive the update, a VTP update with a non-null domain, we are going to actually learn the VLANs. And now in my Wireshark captures that I'm going to show you just in a second, I should be seeing now that the domain is actually set to Cisco. So we can see here that the domain says Cisco. So now these frames are sent. Let's go to cat2 and change the domain. So VTP status, VTP domain IP expert. Now I can see that I'm changing it from Cisco to IP expert, and CDP is now going to start complaining because I have a mismatched domain between my two switches, but that's not something I care about. Let me go to FastInternet24 and I'm going to shut it down. So I'm shutting down the link between cat1 and cat2. Now I'm going to bring it up. And when I bring up the domain, when I bring up the interface, what I'm going to be seeing now there it is. It happened on cat2. It says, unable to perform trunk negotiation on port FastInternet24 because of VTP domain mismatch. So now, on this side here, I'm using domain Cisco. And on this side here, I'm using the domain IP expert. So what is happening now when this frame here is sent? Inside this frame, we had an encoded domain. Switch 2 is now going to look inside this packet and say, okay, does this information here match what is locally configured? If it doesn't match, the trunk will not be successfully negotiated. So if I do show interface FastInternet24 switch port, I'm going to see here that even though this interface was configured to be dynamic auto, it is actually operating right now as the static access interface because we have failed to negotiate the trunk. And by the way, now we are seeing this on cat1 side as well, just a little bit later on. So this is a very, very important interaction between DTP and VTP. Now, why am I spending time telling you this? Because in real life, you are most likely not going to be using either one of these protocols. But in the CCIE lab, remember, these are Cisco's darlings. Cisco likes DTP and Cisco likes VTP. In the lab, they could ask you to perform dynamic trunk negotiation. And you are going to configure this, and they might actually have the logging disabled on the console. So you're not going to see this error message, and you're going to be pulling your hair, and you can see I'm actually out of it. You're going to be pulling your hair out. Why are my trunks not being negotiated? And the reason for that is because your VTP domains don't match. So be on the lookout for this. Now, while I'm on the subject of VTP, there is one particularly nasty thing about VTP that you are probably aware of. It's something that has a nickname of VTP bomb. Now, VTP bomb is when you have a switch, let's say in our case, switch 1, that is configured as client, or it could be server, it doesn't matter, but it must be client or the server, that sends the update to the network that actually deletes the VLANs on switch 2. So if we take a look at this table here, take a look at the client part here. I said it receives the updates from the network, but it also sends the updates on the network. The only thing that VTP cares about when it sends or receives the updates is the revision number. So here we have configuration revision number 1. Now, if I receive an update with a higher revision number, I'm simply going to override whatever is in my database with an incoming update. There is no merging of information, there is no intelligent behavior. Simply what I receive is what I will be using. So to show you why this is dangerous, on Cat1 now, first let me change the VTP domains to match. So I'm going to change this domain to IP expert, so now the domains match. And on Cat1, I'm going to create a couple of VLANs. So VLAN 100, VLAN 200, 300, 400, 500. So if I do show VTP status, I'm going to see here that I have a configuration revision number 4. Now, let me go to Fastnet24, going to shut it down, and I'm going to say VTP mode client. So now I have shut down the interface between Cat1 and Cat2, and my mode right now is client, but you can see that my configuration revision is 4. Let me go to Cat2. So on Cat2, I'm going to change it to transparent mode, and I'm going to change it back to server mode. The reason I'm doing this is that any change to transparent mode is actually going to reset the configuration revision to 0. And let me create a couple of VLANs here. So by couple VLANs, I actually mean 100 VLANs. So if I do show VLAN here, I have created 100 VLANs. So here they are. If I take a look at the show VTP status, the revision number is going to be 1. Now, the reason why revision number is 1 and not 100 is that I have created this 100 VLANs in a single operation. So any operation on the database is a single revision number changed. So here I have VTP server with the domain IP expert. On Cat1, I have a VTP client with domain IP expert. Let's bring the interface between them up. So I'm going to say no shutdown. The interface changed state to up. The line protocol changed state to up. And if I go to Cat2 and do show VTP status, take a look at this. Configuration revision is 4, and take a look at the number of existing VLANs, 10. If I do show VLAN, I no longer have VLANs 101 to 199. I do have 200, 300, 400, and 400 that I learned from Cat1. So this is the situation in which my VTP client actually updated the server and deleted all the VLANs. So if I can reproduce this in a live class in about 3 minutes, what do you think Cisco can do when you start your lab with 4 switches that are fully meshed? Whenever you have a VTP-related task in the lab, whenever you need to change the domain, whenever you need to modify something along these lines, be very, very, very careful. So, how can you actually correctly approach this task? So let's say that the task here was make sure that the domains on Cat1 and Cat2 are IP expert. Okay, so I know that, and don't delete any VLANs. So I know that here on Cat2, I had 100 VLANs. the best approach for this task would be to change the VTP mode to transparent. Actually, do that on both switches. Why? Because then you can do show running config, and in the running config, you are now going to see the VLANs in the running config. So what you can do is you can go to your notepad and you can paste the configuration from one switch, go to other switch, paste the configuration from here without actually looking at it, then change this one here to VTP mode server, change this one here to VTP mode client, and then go to the server and blindly just paste this back in. Why do I say blindly? Because I really don't care what's there. Because what I'm doing now, I'm actually merging two databases. In my case here, they were identical, but in your case in the lab, they may or may not be identical. The interesting question here is, would that work if you hard-coded the ports to trunks, but domains were different? Well, when you have hard-coded trunks, they're not negotiating anything. So they will be trunks. Now, this behavior that I was just showing with VTP bomb, this has nothing to do with trunks being or not being negotiated. Now, if the trunks are negotiated, if the trunks do come up, the VTP messages will be sent across. Now, if the domains don't match, the two switches will not accept each other's messages. So, like ships in the night. Oh, you are in domain Cisco? Okay. Oh, you are in a domain IP expert. I'm not seeing you. Now, the only time when they're actually going to listen to each other's updates is if the domains match. So if the trunks were hard-coded and domains didn't match, you would not have this problem because your VTP is inoperational in that network. This was brief introduction to VTP. I mean, you don't need to know it in much greater detail than this. Now, one more thing about VTP that, I mean, you should really, be aware of is that you can configure the authentication for it. The command for that is VTP password, and you can set the password. And if you forget what the password is, the command is show VTP password. And if it's not configured, it will actually tell you that the password is not configured. So, not much point spending too much time there. This is the most important thing about VTP. Be on the lookout if you are starting the lab and your domains don't match, and if the lab tells you that a certain domain needs to be configured, be on the lookout because you could be actually, by mistake, deleting some VLANs. Now, keep in mind here that they're going to tell you something along the lines of, okay, make sure that your domain is Cisco, and don't delete any VLANs. So you go in there and you notice that something like, along these lines happen, and you think to yourself, okay, so I have the VLANs. You look at the diagram and you see which VLANs are in use and you're fine. Well, what if there were other VLANs added to the database that are not actually in use by the lab? So the lab requirements didn't say don't delete any VLANs that are in use by the lab. The lab instructions were very simple. Do not delete any VLANs. So this is what you've done. But there is no way for you to recover from this situation if you have actually deleted those VLANs, because those deleted VLANs were not actually documented anywhere. So again, be on the lookout for this. So going back to my two switches here, if I take a look at show interface switch port, show interface Fastnet24 switch port. So I have talked about these things here, and I also talked about the negotiation of trunking a little bit. So this line here tells me that DTP is actually turned on this trunk. But how do I turn it off? How can I turn off the DTP on an interface? So here is the question for you. How do I turn off DTP? What I'm hearing here are answers along two lines. One is switch port no negotiate. So let's just write these down. Turn off DTP. So we have switch port no negotiate. And this is something that you would use on static trunks. Then we have switch port mode access. when you enable access mode on the interface, it automatically turns off DTP. But are there any other ways of turning off DTP? I'll give you a hint. Now, mode trunk, as we've seen before, does not turn off DTP because it will actually actively negotiate the trunk. So here, if I have mode on and auto, the trunk will actually form because it will be sending DTP frames. So unfortunately, mode trunk is not the answer, but no switch port is. Because if you have a layer 3 interface, the interface is not going to be sending any DTP frames. So that's a correct answer. What else? Switch port mode private VLAN. I'm going to go with yes. Let me add more. But I'm going to put an asterisk here because this is a little bit software dependent. Switch port mode .1Q tunnel. Now, .1Q, well, yes, technically speaking, yes. Switch port mode .1Q tunnel. Let's add more. Actually, I think that there is only one left. But this one, you have to think way outside the box. Let me help you. If you shut down the port, it won't be sending any DTP frames. Now, of course, I'm joking with this last one. Well, I'm not joking, it's true, but it's not really an operational mode. But still, we have 5 ways of turning off DTP, and it's very important to know when to use one of those. But the most important thing to take out of this is that none of these here are switch port mode trunk. Switch port mode trunk does not turn off DTP, as we can see on the example here. So if I go to my Fastnet 03, and if I take a look at the switch port, we can see that administrative mode is trunk, operational mode is trunk, we are .1Q, and we are negotiating the trunking. And if I take a look at my Wireshark, I'm seeing a bunch of DTP frames sent out. So there is negotiation of trunking. If I want to turn off DTP on that interface, I actually have to use switch port no negotiate.